Okay, we have started the discussion. Uh, Yesterday, we have started the discussion on the design of square bunker. We will do that today. In the problem, they have given the weight of coal, that is 350 kilonewton. Density of the coal is also given, that is 7850 Newton per meter cube. Phi is given angle of repose, that's 30 degree, and beta is also equal to 30 degree. So phi and beta will be equal. Okay, what is beta? Beta is the angle of surcharge. Whatever the material that you have at the top, the material makes angle with respect to horizontal. That is the angle of surcharge. So we are required to use M20 grade concrete and Fe415 steel. Okay. So we have seen yesterday, we have seen the dimensions of the bunker. So in this way, uh, you will have the dimensions of the bunker. H1 is the height of the surcharge, H2 is this height, and H3 is the height of the upper bottom. And V1, V2, V3 are the respective volume of the bunker. Okay. So yesterday we have seen how to find V1. This angle is uh, 30 degree. And you know how to find this H1. H1 tan 30 equal to H1 divided by 1.5. So H1 equal to 1.2 tan 30. It is coming as 0.87. Okay. And since you know the bottom dimension is the square dimension, and at the top it is just like a triangle, it is conical shape. Okay. So the volume V1 equal to 1.3 into 3 into 3. 3 into 3 is the bottom dimension, that is square bunker into height. Height is 0.87. That is equal to 2.61 meter cube. Okay. Then weight is given to you and density is given to you. So when weight and density is given to you, you can find the volume of the bunker. The volume of the bunker equal to divided by density. So weight is given in kilonewton. We can convert that into Newton. And density is 7850 Newton per meter cube. So the volume of bunker that you are getting is V equal to 44.60 meter cube, where V is the total volume of the bunker, and V1 is just volume of the upper part of the bunker. So V equal to, if you want to write like this, V equal to V1 plus V2 plus V3. So from this, what we have gotten is V and we have gotten V1. We can find V3. So once we know V3, V2 can be calculated. Okay. So we'll find some.
सर वो मेरी प्रोजेक्ट का ये था।
मेरे पास नहीं मिनी प्रोजेक्ट. Okay. So V3, what is V3? V3 is, I will let you know. V3 is volume of hopper bottom. Volume of hopper bottom. Volume of hopper bottom. And this is how the hopper bottom is. You have some opening. Okay. So this is the H1, sorry, H3 that you have. And the angle that it is making, that is theta. Theta will be equal to 45 degree. Theta should be greater than phi. Phi is 30 degree, and theta, the slope of the hopper bottom, should be greater than phi. So theta equal to 45 degree. And let's assume that the size of the opening is 0.5 by zero point 0.5. 0.5 meter by 0.5 meter. Okay. Now, if we continue this, if you do it like this, so you will get this distance. Okay. This distance minus this distance will give you H3. I will just call HL or HS. Okay, so what is H3? H3 equal to HL minus HS. So how to find HL? We can use the trigonometry. So this distance is 3 meter and the half distance will be 1.5 meter. So HL will be equal to 1.5 meter because the angle is same. Theta is 45 degree. The horizontal distance and the vertical distance will be equal. Similar here also. This is theta equal to 45 degree. And from here to here, it is 0.5. So this will be 0.25. Since this is 0.25, HS will be equal to 0.25 because the angle is 45 degree. The horizontal distance and the vertical distance will be equal since angle is 45 degree. So HL is 1.5 and HS is 0.25. So you can find H3 will be equal to 1.5 minus the height of the hopper bottom. 1.5 minus 0.25. So this is coming as 1.25. Okay, 1.25. Okay. So how to find V3? There is one formula to find V3. V3 equal to H by 3 into A1 plus A2 plus under root A1 and A2. Okay. What is A1? Area of the top portion. 3 meter by 3 meter. What is A2? A2 is the area of the opening. That is 0.5 by 0.5. And what is H? H is the height of the hopper bottom. That is H3. Okay. H is the height of the hopper bottom. Here we have written it as H3. So we can use this formula and we can find V3. V3 equal to H, that is height of the hopper bottom is 1.25 divided by 3. A1 is area of the top portion of the hopper bottom, that is 3 by 3. A2 is area of the opening, and we have assumed the dimensions of the opening, that is 0.5 by 0.5, 0.5 into 0.5 plus A1 in under root A1 into A2. A1 is 3 into 3 and A2 is 0.5 into 0.5. Okay. So V3 that we are getting here, V3 equal to 4.48 meter cube. Okay, so we got V1 plus V2 plus V3. So from this, what we know? We know V1 and we know V3. So V2 can be calculated. What is V2? V2 is the the volume of the cylindrical portion or the middle portion of the bunker. Okay. So again, I will find V2. V2 equal to V minus V1 minus V3. So what is V? Already we have calculated. V is 44.60. 44.60. V1 is 2.61 and V3 just now we have calculated, that is 4.48. So V2 equal to 37.51 meter cube. Okay. So here again you go to the dimension of the bunker. Go to the dimension of the bunker. So here H1 is known to you. H1 is 0.87. H3 is 1.25 and H2 is not known to us. But we have calculated V. Since we have calculated V2, we can find H2. So what is V2 equal to area of the bunker into H2? And what is the area of the bunker here? Area of the bunker, that is square bunker. Are you getting class? Am I audible?
Yeah, audible, sir.
Okay. So V2, you have calculated V2. It is 37.51 equal to 3 into 3 area of the bunker into H2. We have to fix the height. We know H1, we know H3, but we don't know H2. Now we need to fix the height of the bunker. So H2 here you're getting 4.17 and that can be equivalent to 4.20. Okay, so this is the value of H2 that you're getting 420. Since you have increased the height, V2 will change. Okay, V2 equal to area of the bunker into H2 is 4.20. Area of the bunker 3 into 4.20. Okay, so V2 equal to 37.8 meter cube. Okay, so we can find the actual V1 plus V2 plus V3. So what is V1? V1 is, okay, what is V1? V1 is 2.61, 2.61, and V2 is 37.8, okay, and V3 is 4.48. So the total volume of the bunker is equal to 44.89 meter cube. So this is what you're getting at the end, and you have fixed the dimensions of the bunker. You know V1, V2, V3. You know H1, H2, H3. So dimension as far as the dimensions of the bunker is concerned, it is fixed now. We can move forward in the design. Now, since you have changed the volume, weight will also be changed. Because what is weight? Weight equal to volume into density. Okay. So weight will also change because you have increased the volume of the bunker. So weight equal to weight of the coal, volume into density. So what is the volume that you have gotten? That is 44.89 into density is given in the problem 7.85. If you write in kilonewton, it will be 7.85. So which is equal to 352.40 kilonewton. So what weight is given in the problem? The weight given in the problem 300 kilonewton. So whatever weight we are getting, it is more than that. So it is okay. We can proceed with the design. Weight should not be less than this. It should be more than this. Then and only you can proceed with the design. Okay. So now next thing we have, check for bunker action. Whether the problem is bunker or not, we need to check it. Okay. So next thing we have is check for bunker action. Check for bunker action. So when we are calling it as a bunker, I have discussed about this. You have to draw the line from the edge. If this line, intersect the horizontal surface, then we can say that this angle is 90 plus pi by 2. If this line intersects the horizontal surface, then we can call it as bunker. That line is intersecting in case of silos. If you draw angle with respect to that line will intersect the opposite wall. It will not intersect the horizontal surface. It will intersect the opposite wall. So in that case, it will be known as silos. So we need to check whether our whatever the dimensions that we have fixed, whether it is for bunkers or silos. We need to check for bunker action. Okay. So how to do that, I will tell you. I will take this as this this angle is this angle is 90 plus pi by 2, and I will fix height. This height is y. Okay, and this dimension is 3 meter, the dimension of the bunker. Okay, 90 plus. So what is y? Y equal to b into tan 90 plus pi by 2. Okay, so if you do this, y is equal to 5.20, which is greater than h2. Since it is greater than h2, then this line will intersect the horizontal surface. If it is less than h2, what h2 you have? H2 is 4.20. Okay, if it is less than h2, then that line will intersect the opposite wall. So since y, that is 5.20, which is greater than h2, then we can say that whatever the line that is coming from the edge, it will intersect the horizontal surface. Okay, so whatever the things that you're designing, whatever dimensions that you have set, that is bunker. Okay, you can write here. It intersect the horizontal surface, horizontal surface, horizontal top surface. Okay, design as bunker. Design it as bunker. Design as bunker. Okay, up to this is clear? Class, you have any question? What we have done, we have fixed the dimension of the bunker. We have calculated the volume. We have calculated V1, V2, V3, and then we have gotten total volume. And we have changed the height of the bunker, that is H2. H2 we got 4.17, and we have changed it to 4.20. And the V2 is increased because of that, and volume is also increased. So since volume is increased, weight is also increased. So we have calculated weight according to whatever volume we have gotten. And then we have done whether whatever dimensions we have, decided, is it bunker or silos? So we have done that, and what we are getting that it has a bunker. Okay. Any question, class? Class, you have any question? Hello. Am I clear up to this?
Yes, sir.
Okay. So next we have design of sidewall. Two elements you need to design in the bunker. One is the sidewall and the other is the hopper bottom. So up to whatever we have done up to this is only deciding the dimension and calculating the volume, calculating the. We have not come yet up to the design. when you're talking about the design of bunker, you have two elements. First is design of sidewall, and second is design of hopper bottom. So we will start with the design of sidewall. Okay. Design of sidewall. Okay. So this is the sidewall that you have like this. And below this you have hopper bottom. So in the sidewall, the maximum pressure is acting at the bottom because the pressure is the function of the height. You know the formula of the pressure? Pressure pH equal to gamma H cos square phi or beta, whatever. Okay, both are same. So more the height you have, the more pressure you will get. So this is our H2, which is equal to 4. Okay, so the maximum pressure that you will get is at the bottom of the side wall. Here you will get the maximum pressure. Okay, pH equal to gamma is 7850, that is Newton. It can be converted into kilonewton, 7.85. 7.85 kilonewton per meter cube into H. H is 4.2, that is H2. H2 is the height of the side wall, 4.2 into cos square. Phi value is given in the problem, that is 30 degrees. So pH is coming as pH equal to 24.73 kilonewton per meter square. So this is what you're getting. Okay, that is pH. This is pH. The maximum value of pH will be at the bottom because it is the function of the height. As the height is increased, the pH value is also increased. So at the bottom, you're getting the maximum pH or lateral pressure, that is pH equal to 24.73 kilonewton per meter square. 1 second. Okay. Okay, so we will assume the thickness of the wall. Assume the thickness of the wall. Thickness of the sidewall. See, this is the sidewall that you have, and it will have some thickness. So we'll assume the thickness of the sidewall. Assume the thickness of the sidewall. Thickness of wall equal to 180 mm. 180 mm. Okay. Now you see, this is the one side wall, and this is the another side wall that you have, and the distance between them is 3 meter. Clear distance is 3 meter, and the thickness of the side wall is 180 mm. But we need effective span. The effective span is distance between center to center. Center of this thickness to the center of this thickness, that will be equal to 3 plus 0.18. Okay, so the effective span L effective equal to 3 point. Hello class, can you able to hear me?